Hello and welcome again to Training for Hub Leaders in Child Development. In this video, we're going to look at some perspectives from neuroscience in relation to child development. We're going to start by looking at some theories of the brain again in a slightly more detail than we did so in the earlier video, and then briefly look at an evolutionary perspective on the development of the brain. We're going to look beyond the basic concept of nature and nurture into some modern developmental perspectives on the brain and how the brain works. And then we're going to look at some concepts which seem fairly simple or simplistic, but have proven to be quite useful in practice for practitioners working in the development space in recent decades. When we look again at theories of the mind or theories of the brain, we see that these range quite broadly from biological and physical based definitions through to ideas which are quite creative and metaphorical in nature and don't seem to have a lot of grounding in the physical status of the brain or the physical makeup of the brain. These theories vary quite widely and often don't relate very well to each other at all. So it's quite a curious space of research, actually, that there's a lot of ideas that don't blend very well together. And it can be quite confusing to look at it from one theory to the next. One very early theory about the brain was that there was a general intelligence, or G was kind of a shorthand version for it, like a single intelligence which just did everything one way, in one particular way. This idea has broken down or developed over time. There were some fairly strong theories that have been developed around the hemispheres of the brain based on the physical biology of the brain, and this has extended into theories around modularity in the brain, so understandings of specific aspects, or specific parts of the brain which have particular functions. So in some cases, we can actually identify certain areas in the brain that seem to activate for certain functions, such as Broca's area and Wernicke's area, which are related to the ability to speak and the ability to understand language. These seem to have developed as physical locations in the brain dedicated to these functions, and at some time in the evolution of the brain, there's been a connection between these two areas by a specific bundle of nerves. So that's one example of a modular understanding of the brain, that some parts of it seem to operate in certain sections. But this certainly isn't the case for a lot of functions of the brain. So for instance, memory doesn't seem to fit in any one particular part of the brain. So there's been theories such as neural network theory that suggests that some functions of the brain operate not in a particular physical space in the brain, but as a particular linkage between certain neurons, certain synaptic relationships between neurons. So rather than having to fit in one part of the brain, any part of the brain can undertake certain functions if the configuration between neurons can be made. That's one particular theory, the neural network theory. There are other, I guess, more creative theories, thermodynamic theories of the brain, free energy theories, holonomic theories. I won't go into too much detail about those, but if you're interested, by all means, have a look at those and see what other theories of the brain you can find. The list does go on. It's really hard to pick between these, and one way of looking at it is to look at the actual long-term history of the mind, or the evolution of the mind over millions of years, beginning with pre-human ancestors of humans. One anthropologist or archaeologist, Stephen Mithen, has developed a theory about 3 phases for the evolution of the mind. This might be a fairly simplistic model. It might be more detailed than this. But it's an interesting concept. It's certainly strongly contested in the archaeological space because there's no real way of proving this this idea scientifically, so it's viewed with some skepticism by a lot of archaeologists. But the basic idea that Mithun has is that at a very early stage of the evolution of the human brain, there was just one single general intelligence. But over time, the minds of the creatures that had these brains developed new specialized intelligences in the areas of social intelligence, the ability to use tools, so technical intelligence, understanding of nature, and other specializations. And so that these were fairly distinct specialized parts of the brain. And then at some stage in the evolution of the brain, these minds found all of the specialized areas blending together and working together, and thus creating an overlap of the general intelligence with social intelligence, natural history intelligence, technical intelligence, and ultimately of language. And so what Mithun suggests is that this overlap of specialized functions, this multiple overlap, results in an ability to have symbolic intelligence, because you need to be able to abstract away from all of the specialized intelligences to be able to interpret between them. It's a very interesting idea, again, something which is virtually unprovable, but perhaps gives us an insight into the complexity of the evolution of the mind, and perhaps gives us a way of incorporating a lot of the specific ideas about the makeup of the mind. It may be the case that all of those different ideas have evolved in some form over the whole history of the development of the mind. So it's better to look at it from a synthesized perspective rather than trying to pick one out of the many possible theoretical options. So that kind of thinking about the evolution of the mind really is a lot more complex than a lot of the ideas that have historically been held about the mind. And for a long time, there was a battle between biologists and psychologists around nature versus nurture. So were people shaped by their biological nature, their natural selection, or were they shaped by their experiences after birth, their social and psychological experiences? Of course, it's pretty common sense to suggest that there's a lot of both of those in the makeup of everybody's brain. Reality is going to be much more complex than any kind of duality or binary argument of that nature. And there are developmental psychologists who've done a lot of work in recent decades to support that notion. Elizabeth Spelke is one of those. And so she and her colleagues have done a lot of work with very young infants and babies to demonstrate their ability to understand spatial concepts and other types of concepts before the age of 1, where there's really no way that they could have learned. They couldn't have learned those concepts or been able to demonstrate an understanding of those concepts through education or through learning from their parents. It gives some sense that there's innate knowledge within human minds, which must have come from many, many generations of life beforehand, really. Very, very interesting work. Annette Karmeloff-Smith is another one who's developed a theory around the relationship between behavior and internalization. And she talks about children collecting stimuli from the environment, imitating it in behavior without understanding what they're really imitating. And we've all seen this if we've seen children imitating older children or imitating their parents or so forth. And then at a certain stage, children start to internalize what they're witnessing through repeated exposure. They're developing experience and context. And then finally, their internal representations come to match what they're seeing on the outside, and they can develop their internalization and their behavior together. So Karmeloff-Smith has really made a lot of effort to explore the subtleties between behavior and the internal processes of the mind in quite a lot of depth. And she goes beyond this to talk really about the structures of the mind that make this possible. So we really have to think of the mind as something which has some kind of innate structure that makes learning possible, that makes learning within context possible in a certain way. So that's all fairly complex material. How do we actually apply that in working with children? What I've come to find in all of this is that sometimes there's ideas about or concepts about the mind and how it works, which seem quite simple. And over decades, they've just kept coming up and kept being used in one context after another. And it seems like it's possible, with all the complexity of the mind, to find some kind of statement about how it works, which seems to apply across a lot of contexts. One classic example, I think, is Maslow's hierarchy of needs. It's been around for several decades. It's the standard criticism of this is that it is an arbitrary structure. There's no evidence in the brain that it looks for these 5 particular needs in order. So there isn't really any empirical proof of it. But it has come into play in a lot of different contexts, a lot of different practices. It seems to match, in a way, the way that people experience their lives. It's been developed through observation and through people's response to these concepts. Looking at another similar kind of model, which is more directly geared towards child development, we come to Gardner's multiple intelligences. So Howard Gardner came up with a series of specific intelligences, which he believed, if you pursue each of these for children, give due attention to each of these, you're developing the whole child. Now, the number of intelligences is not really very heavily fixed. Depending on where you look in research or on the internet, you'll find there's 8 intelligences, 9, 12. People keep adding to them. Gardner himself kept elaborating on this theory. But you can start with any one of these models, really, and given 8 or 9 or 12 different areas to pursue. If you have developmental activities developed for each of those for children, you're doing a fairly comprehensive job in developing children's minds and giving them a lot of exposures that are going to help them throughout their life. So there are a number of systems of education and learning activities that have been developed based on Gardner's multiple intelligences. And there's other models of that nature which can be looked at. So I guess in all the complexity of looking at the mind of a child, in all the complexity of the concepts that have been presented in the videos up until now, what it boils down to is you can learn as much about that as you want, but then as long as you can bring it back to something practical and straightforward like Gardner's model, you're going to have something that will work in a child's play and learning context, which can draw as much as you want from all of the research and all of the theoretical understandings that have been developed. So a few resources at the end of this topic on neuroscience. There's an interesting website called Neuroscience for Kids, which the aim of it is to develop understanding about neuroscience for children. It's quite an accessible site in terms of getting some broader understandings about aspects of the brain. And depending on the children you're working with, there might be a few things on there that you can look at applying as well. But it's certainly worth looking at in terms of developing your own general knowledge about neuroscience. There's a number of links there around multiple intelligences, around particular activities that can be done with multiple intelligences. It's a great place to start, and there's definitely other resources in terms of developing practical approaches to child development. I think this is a great place to start.